Hello, everyone. I see a few more faces have came in now. Everybody in the back, if you could come sit down, take some seats, that would be great. Hello, hello. So, now we will start the restaking portion of the event. I'm Rickert. I am with Blockswap, and we have a new protocol called Blockswap Cloud, which I'm about to take you through. Here's a brief summary of what we'll be going through. Start off with what is restaking, what are the different types of restaking, because not all restaking is equal, and what is needed to have some successful restaking. From here, we'll move into how can we reuse existing Ethereum infrastructure so that we're not starting from scratch. How can we pull in DVT technology? How can we pull in some of these other ecosystem players? From there, Matt will be joining me up here, and he will be taking you through more of a deep dive and explaining a lot of the mechanics behind Blockswap Cloud. So first, what is restaking? You could consider taking an LST as staking, and I suppose you could consider putting it into Aave or some sort of farming as restaking, but that's not what we're talking about here. What we're talking about is actually fractionalizing Ethereum infrastructure and making it reusable, making it composable, making Ethereum reusable without putting additional stress on the ecosystem. What it can do is give us faster innovation, and it can allow for protocols to scale much more quickly. And it can kind of give a little bit of a reliance for some of the members of these protocols. As I mentioned, there are multiple types of restaking. The first is extending economic security, and that's simply saying you have assets, you have some sort of LST, and in return, there can be a node operator. This doesn't have to have anything to do with Ethereum. It doesn't have to have anything to do with any particular network. But if there's an agreement, and if this node operator misbehaves, well, then there's some risk in play. That's the economic side. Now, extending Ethereum validator security is a much higher level. This allows for these different protocols to plug into particular restaking parts, particular parts of Ethereum consensus. Now, there can't be extending validator security without economic security, but there can be economic security without extending validator security. So how much security is out there? If we take a look, there's 15.7 billion settled per day on Ethereum in transactions. Now, there's only 40 billion staked, so what that means is that in 3 days, we're already well beyond the amount of Ethereum that is settling all of this. So when we take a look, currently we have 20% staked, 10% is liquid staked, 10% is non-liquid staked. Now, if the market expands and it doubles, for example, we have more solo stakers, this is amazing, there is a smaller proportion that's liquid staked while more is staked. That means that there's more validator security available, but there is not as much proportional economic security available to restake, which is why it's so important to push this settlement security, validator security, over just economic security. So just sort of a thought experiment here. What if transactions move to L2s and the amount of solo stakers go up? Well, issuance will go down. There'll be less per validator. The number of blocks per validator goes down, so presumably less MEV per validator. A lot of these rewards get split, but the amount of validator security that we're talking about goes up. So this becomes the next opportunity for validators, for Ethereum node operators. These are the players. We have this concept of shared liquidity through LSTs. Similarly, there's shared infrastructure through DVT, and then there's the solo stakers. And all of these can participate in restaking in their own right. Here's a quick look at the ecosystem. We have the infrastructure on the bottom. We have the DVT, the node operators, these LSTs, All of this holds up and builds the bridge, which is Blockswap Cloud, where L2s, oracles, lending markets, dexes, whatever you want to build can come on top. So what does this take? Well, we have to start off with creating something that's fungible. ETH does not equal a price feed. ETH equals an ETH regardless. And similarly, validators are all unique assets. Whether you're clumping them together or they're part of validator pools, whatever it might be, they need to be seen as a separate asset, not as a group of validators, if we want to utilize them to extend security. So for providing liquidity, those who are holding LSTs are already looking out for their own best interest, and they want to reuse those assets. Otherwise, they wouldn't be liquid staking. They could stake by themselves. So they're already willing to take on this risk. They're going out in DeFi. They're finding additional places to get revenue. They're looking really for the best yield, and maybe they want it to be part of, an Ethereum validator, which is actually restaking their ETH in the first place. Maybe they want to trust it again, sort of double down on this restaking. Now, I was touching on this a bit before, and I'm not going to go too into depth here because later we'll have Matt and Vince talk about KETH, which creates that unified risk profile for all LSTs. But essentially what it does is people can add any LST, they can get KETH, and they'll always be able to redeem ETH, a smart contract path back. I'm not talking about swapping, I'm talking about redeeming ETH. So LSTs have a particular advantage here because they have a lot of the infrastructure, they have a lot of the liquidity, and when in the case of Blockswap Cloud, they could decide who is able to access these different these different agreements that are available on Blockswap Cloud. What's great is there's an in-house rating system for Blockswap Cloud, which allows for people to get an idea of what is the quality of this node operator. I'll get into the rating system a bit later. But it allows them to decide who's performing optimally, who's not. And what's very interesting is with Stakehouse, Stakehouse allows for people to create their own LSD networks, and there could be LSD networks built just for providing security to particular middlewares. Now, there's a few questions around Ethereum infrastructure. How Ethereum is the largest node operator set. How do we reuse the security? How do we fractionalize the infrastructure? How do we safely do this? And can it be plug and play, very easy to use? Yes, obviously Blockswap Cloud. So when we're talking about the validator rating system, we need to look at what an Ethereum validator needs to do. An Ethereum validator needs to maintain Ethereum network. That's first and foremost. So the rating system in Blockswap Cloud is entirely based off of how the validator is performing in Ethereum. If they're performing optimally, well, they get the highest rating. If they start slipping, they start missing attestations, whatever it might be, well, they get a little bit lower rating. If they get a lower rating, they can't get as many jobs because people might only want to hire premium, high-quality validators. So this makes validators particularly substantial assets in Ethereum. And I think a little hypothetical story can kind of paint a little picture of what this marketplace looks like. So imagine that there's an L2 who wants to build on Blockswap Cloud. And they want to use the attestations. They want to plug into Ethereum consensus layer. They want it to be based, every time it attests on Ethereum, they want the validator to attest for their L2 as well. They're just starting off. They need 5 validators. They don't really care. Very, very small, kind of a proof of concept. They don't care if it's plugged into, these are the best validators, whatever it might be. They can get it from anywhere. Now, let's say they start to scale. Say they need 200, 300 validators, but they don't want to pay for 200 or 300 premium validators, they could create a subcommittee, get the premium validators for 50 of the validators. Maybe they're doing that all through DVT so that they're automatically decentralized and they have the robustness of having multiple operators per validator. But for the rest, for the remaining validators, maybe they just need the economic security. They don't care about how well they're performing in Ethereum because they just want to have that economic security. Now, in another way, if some of these premium validators decide, hey, I'm going to pick up a bunch of these SLAs, I'm going to start to overload my node, and things start to slip a little bit, well, they might lose the job. And the middleware, this L2, is able to say, hey, you're not performing as specified. I'm going to get rid of you. I'm going to hire another premium validator instead. So this really supercharges DVTs. Multiple ways, really. So what it can do for DVT is people can see them as a premium option. There's 4 people who are protecting each validator. And on top of that, each one of these node operators has access to the Ethereum validator. So now there's more people who have access to Blockswap Cloud, and at the same time, they can provide more reliable service for these middleware. Okay, so now what this does at a very, just to kind of sum everything up, is we are making Ethereum composable. We want to give people the option to reuse particular aspects of Ethereum consensus for their middleware so that they can scale more quickly. It gives more time for developers. People don't have to worry about where they're going to get security from. They can hire it. And again, there's economic security and there's this consensus security. And Matt and Vince are going to get into sort of the details here. First, Matt is going to step in and give you some of the details on some of the mechanics, and then Vince will get into how to provide economic security simply. But before we do, there is this in-protocol currency called cloud credits. And because everything here is based off of ETH, it's the Ethereum consensus layer, so cloud credits will be based off of ETH. So if you take a look, 1 cloud credit equals a value of 1 ETH, but to get the cloud credits, you will burn BSN tokens equal to the value of ETH at the time. So if, for example, Ethereum's $2,000 and BSN's trading at 50 cents, well, it'll take 4,000 BSN to get access to 1 cloud credit. Now, cloud credits can be used in multiple ways. The middleware, it's sort of a pay-as-you-go AWS sort of thing, where the middleware can get these cloud credits and they can get access to validators. They pay a little bit more for premium validators, pay a little bit less for less premium validators, whatever it might be, but it's up to them. When the cloud credits run out, they top up or their services are cut off. Now, the Cloud DAO, on the other hand, this is how middleware come in. Those in the Cloud DAO can pay cloud credits to get a portion of the slashing, any portion of the fees paid by the middleware. And the only way that middleware can come in is by being vouched for by the Cloud DAO. The Cloud DAO brings in the middleware. This is a completely decentralized protocol where there's no centralized party making decisions who can participate, who's not. It's all DAO. Now, finally, there's the Grant DAO. And the Grant DAO will allow protocols who are starting up, who say maybe want to get funding for development or access to Blockswap Cloud, they can go in there and get grants. And they can get grants both to build, but also a lot of them will come through as cloud credits for them to spend to access this security. And now Matt will join here to go through some more of the technical aspects of Blockswap Cloud.
Thank you, Derek. Good morning, all. Great. Much of Matt. We're going to delve deeper into how the cloud works. So essentially, Blockswap Cloud is a dual stake, dual opt-in system which completely works on smart contracts, fully trustless. So there are let's set the scene first. What are we trying to do here? We are extending the security part to external actors. These are different, middlewares or L1s or rollups, L2s, you name it. But they need trust. They need, stake capital. They need decentralized infrastructure as a backup to grow quickly as possible with credible commitments. So we have this kind of SLA contracts called stake lease agreements that will automate the whole process. And there's a payment contracts called the payout pool. And there's a ZK system that takes care of the slashing logic. In between this, you have KETH. That's a neutralizing factor because we have all kind of LSTs. We're going to get into those in detail in the coming slides, but this is the overview. So let's jump in. Cool. So the key technology behind Blockswap Cloud is the state replication. That's been built internally by the Blockswap team it's been in production for the last 11 months. How do you get a consensus layer state into Ethereum? And now what we're trying to do is how do we actually get any state from any external environment into a smart contract? So think it about a data smart contracts in a deterministic manner. So you can literally get either state from a rollups or from Oracle, from any external things, and you can make programmable decision based on that one. And then the smart contracts will automate the whole process. And that's the key part that's holding everything together. And the other thing is the reporter part, right? Reporter works with a proof-carrying data modeling called the RPBS system, and that's been in production. It's super fast. It's about 100 milliseconds. That's to create any kind of proofs, and anyone can run it with a very lightweight software. So, how does it look a restaking from a credible commitment? So the whole thing works on a contingent outcome basis. What does that mean is you say, I will do X, and then you will not do it, you will not get paid. But you need to know how to prove that because these things actually happens off-chain, right? You don't know, there's no Oracle here, so you cannot take anything from there. There's no peg, there's no light client, nothing. So the reporters will actually do that for an incentivized manner. That's how the replication of the state happens on the chain. Every party will claim the money disproving what they have done. So you come and you show the work and you get the payment. And there are market actors can do that. Think it how the Uniswap price will actually get fetched to in parity with the external system. The arbitrageurs make it because they have an incentive. The same way it happens. And there are other things that you can see here is all the staking SLAs. You can have mini SLA pools. What does that mean is when you hire validators, you can profile them. I want the validators from DVT, like a Diva or things like that, or I want validators who are running DApp node machines. And I want validators who belong to some DAOs. And you can incentivize them in a separate pool and they will get that drip. No one else get it, but that will actually get collected. And all the payments are processed on a weekly basis. So it's all automated. You can programmably assign what kind of community that you want to have as a middleware and you want to grow it. So it's a very much, seeing like a protocol, working like a protocol, and you're controlling the off-chain environment. Right? It's very modular SLAs. You can write anything, those can write anything. So any ERC20 payouts are possible. So if you're paying, you can pay in your own token or USDC or anything or wrapped ETH, right? So the architecture is a bit still here is you have this kind of registries. That's the key part, which has all the validators who are registering. So if you're running a validator, you register with us, the contracts, and it will automatically take your BLS keys, and then it will take all the state, and it just keep appending all the states there. Then the middlewares, they should also register. When I say register, what is that? Is you just go and you MetaMask and you connect it and you sign an operation, that's it. And that's what's happened here. It will automatically take all the information. Similarly, the other actor in the system is called the ZK reporters. They also register. So all these three actors register, and then everything is in smart contracts. Now it's just start tracking. And that's a registry thing. Registries are especially a special grade smart contracts will be capable of processing off-chain states and make it an on-chain representation, right? And the stake lease agreements, as I explained before, you can have programmable. That comes with the three main factors. Like if you're doing an SLA, it comes with a duration, it comes with a payout, and it also comes with a slashing logic. How do you want to slash it? What is the logic? So if you're Oracle, if you miss some price feed, okay, this is my per event slashing. And if you're like in rollups, the sequencer, you want to run that one, then you just mention that what is the slashing logic. And once you inject it, it will automatic. It just keep going. The reporters are the CK. An RPBS system is an interactive one, but you can actually do the self-attestation scheme. But all that things are on the smart contracts, but the off-chain part is like all the external networks, like let it be, you want to do streaming service gaming or metaverse or ZK validators, anything that you can plug in. You don't really have to think too much. You just register as I mentioned before, in the smart contracts. Your keys will take it, and then you just put the slashing logic, and the reporters will run a software for watching your network, that slashing event, and will get registered here. As a new protocols, they want to grow quickly as possible without thinking who is going to provide the network security, who is going to provide the capital. They can grow quickly with this system. So it's really, really accelerating the innovation in the scene. And not only for Ethereum. So it's very important to understand is like, even though we have alt EVMs, all the alt networks, they have this kind of a special curve, Edward curve, which is not supported. Like if near and things like this is a big thing because we don't have precompiled. So cloud actually support those precompilers are not supported by the existing Ethereum system, so that can be injected automatically into the system. So that's also possible. You don't really have to do more work to get that stake capital, right? So how does this actually work? We said it's all automatic. You register, smart contracts will do it. But the people who are serving the market, people who are availing the market, that need to be equilibrium. The service, the demand and services need to always be tracked. The utilization ratio is that the one that is actually keeping check, the cloud credits. So it will check all the consensus state on a consistent basis. So whenever you subscribe for a service, it will consume your credits, and then you have to that you can have 100 services or 1,000 services. Depends on how much slashing that you can take in. So not every service in same shape or size. Some of them are mission critical. Some of them are like lightweight. So it depends on what kind of service that you want to run, what kind of slashing risk that you want to take it. You can just register for that, and it's this is the equation that's actually taking care of that. So this is just a simulation. That's what if the 100 services that you're running on a slot-by-slot basis, the 12 seconds to get updated. And if you goes below the threshold, you get kicked out, right? The reporter has that one. So that's how it works. Sorry. So the ZK, the RPBS system that's actually helped keep things in check and keep them optimally, optimal equilibrium. So watch out. Consensus layer, which is where all the validators are there. If the validators are not present, it's got equivocated. Like you don't really have any kind of staking capital or anything there. It's dumpster fire, like it's zero. It can go to zero. So you don't want that. You want whatever the security that you are sourcing from consensus layer, it needs to be in check. So it checks that, and then all the middlewares, the reporters are opt-in, so the reporter can opt in for 1 middleware or 100 middlewares. They will check for that one. So these events are always continuously checked, and they're slashing. And they submit the ZK, it's deterministic. The slashings are immediately done, and they can get the payouts. No waiting period, no withdrawal credentials, no margin call, nothing like that. It's all very atomic. It's all real world, and they can claim their money, and they can go home. So this is how it's going to be. It's a bit of a graphic showing that when more and more and more services start to get this in the standards, what's going to happen with the operational cost for running a validator and the capital, it will accrue. When you have this kind of market grows bigger and bigger, you will have this kind of a geo-decentralization to be in a much more wider sense. People can run the machine, and then they will earn while they're sleeping. But it's also important that every attestation on Ethereum will actually going to be supporting other networks too. So it's the global settlement layer, literally propelling the innovations everywhere. So that's the vision of the cloud, just making sure that's a decentralized infrastructure available for everyone and can reuse it in the multiple layers. We are yet to see that many other amplification of the capitals. We'll see other talks today. Yeah, so this is how it is going to be. Right. So if you want to go learn more about the cloud, you can go to the website. That's it. We'll be more talking about how do you take on the restaking part on the ETH in the coming sessions. Thank you.